We're going to be looking at dividing polynomials. And remember, polynomial just means, like polygon means many sides. Poly means many. Polynomials is my many terms. So a polynomial has two or more terms. For example, this is a binomial here. This is something you've seen, which is a quadratic. This is a trinomial. So we're going to look at the different types of polynomials and how to divide them. Now, talking about division, back when you were little and you were in elementary school, you learned about how to do division with just two numbers. So let's just do 378 divided by 9. How would I do this? Well, my first step is I want to see how many times 9 went into 37, because I'm trying to get 37 to go away. So I'm going to say 4 times. So then I multiply 4 times 9, and I get 36. And then remember, you subtracted, and you got your difference. So I had a 1. Then I would bring the 8 down. So then I would try to figure out how many times 9 went into 18. And that's twice. 2 times 9 is 18. You're subtracting, and you get 0. So what that told us was 9 times 42 exactly equaled 378. Those two are factors of 378 because there's no remainder. You're going to execute polynomial division in the same manner with the same principles, except you're going to be multiplying at times with constants and variables together, and sometimes variable against variable. So you have to remember your exponent rules and how to combine constants and variables. So let's set this up. Well, in the first one, I have this long, what we call a quadrinomial, 1, 2, 3, 4 terms divided by this binomial. How do I write it? Same way you wrote this one. So I have r cubed plus 2r squared minus 7r minus 12, divided by r plus 3. Do you see how I wrote it the same way? I even color coordinated it for you so you can see it. So how do I execute a long division that's not numbers, but that is variables and a collection of terms? Well, you're going to do this same thing. Sorry, I'm yawning. The same thing you did here. How many times does 9 go into 37? Well, here you're going to look at lead term, lead term. How many times does r go into r cubed? Well, how many times, what do I have to multiply the r by to get r cubed? And that answer is r squared. Now, r squared times r is r cubed. That's what I'm looking for. You can see those two match up. But remember, I have to multiply by everything. So r times 3 is 3r. Sorry, r squared times 3 is 3r squared. Now, just as I did over here, I am subtracting this whole thing. I didn't need to do parentheses here because it was a single value, a single term. Here I've got multiple terms. I'm subtracting the whole thing. So r cubed minus r cubed goes away. And then I have 2r squared minus 3r squared, and that gives me negative 1r squared. Now, you don't have to write the 1. Sorry, my program is acting funky. You don't have to write the 1, but I'm going to do that just for reference so that you can see it. So, what do I do next? Well, what did I do over here? Well, I brought down the next term. I brought down the 8, so I'm going to bring down the negative 7r. Okay? So, now let's go lead term again. I'm going to compare that to this. And actually to the whole thing. So I want to make r turn into negative r squared. Well, how do I do that? I'm going to multiply it by negative r, because r times negative r is negative r squared. And then I have to do the same thing. What's r? Negative r times positive 3, negative 3r. Now, once again, this is negative r squared. You can't see it. I have to subtract the whole thing. So I'm going to subtract the whole thing. So negative 1r squared minus negative 1r squared obviously cancels. Negative 7r minus negative 3r. Minus a negative changes to a positive. So I've got negative 7r plus 3r. That gives me negative 4r. Then I'm going to bring down the negative 12. And that's my last digit to bring down. So how do I get from r to negative 4r? Well, I'm going to multiply it by negative 4, because negative 4 times r is negative 4r, and negative 4 times 3 is negative 12. Always put your parentheses, and I'm subtracting that whole thing. So negative 4 minus negative 4 cancels, and negative 12 minus negative 12 cancels, and that gives you 0. When you get a remainder of 0, that means that whatever you divided by, the r plus 3, is indeed a factor of this big expression. If you get a remainder, that means what you're dividing by is not a factor of what you were dividing with. Because in order for this to be a factor of this expression, this has to divide completely perfect. And it does. In this case, it does. But if you come out with a remainder, it doesn't. So what this is basically saying is r plus 3 times r squared minus r minus 4 is equal to r cubed plus 2r squared minus 7r minus 12. Let's look at another one. So those are cubes. Let's jump down here. I'm going to go ahead and erase the original example. If it'll let me. It's freezing up on me right now. So I'm back. My document froze up on me. I'm going to erase this and get this out of the way so that we can do number 4. So let's look at number 4. Number 4, we have a 4th degree term, and I'm going to blow this up a little bit. So we're going to do the same thing that we did a while ago, and I'm going to put v to the 4th plus 9v cubed plus 8v squared minus 17v minus 10 underneath. And I'm going to divide that by v plus 2. So let's do our first check. I need to get this to look like v4, v to the 4th. How do I do that? I multiply it by v cubed. So v cubed times v is v to the 4th, which is what I want. And v cubed times 2 is 2v cubed. They're all positive. And remember, you're subtracting the entire thing. So v to the 4th minus v to the 4th goes away, which is what we want. And then 9v cubed minus 2v cubed is 7v cubed. Then I'm going to bring down 8v squared. So now let's move on to making this look like this. How do I make v look like 7v cubed? Well, I'm going to multiply it by 7v squared. So that gives me 7v squared when I do my multiplication plus 14v squared. And how did I get 14? That's 7v squared times 2. Again, parentheses. Subtraction. Those cancel, and then 8v squared minus 4v squared is negative 6v squared. And then I'm going to bring down the negative 17v. And let me move this up a little bit because we're running out of room. And again, I'm Having some issues with my program. It's not wanting to move. Well, we'll see what we can do with it. So now I want this to look like this. So how do I make v look like negative 6v squared? I multiply it by negative 6v. So now I have negative 6v squared. And then negative 6v times positive 2 is negative 12v. And again, you're subtracting that. So you're going to end up with, those are going to cancel. And then you have negative 17 minus 12. That's going to give you a negative, oops. It's not letting me manipulate it. I'm back. I apologize. This program is really stalling out on me and giving me problems. So those go away, and then I have negative 17v minus 12. That gives me minus a negative 12. And that's minus a negative, which is positive. So that gives me negative 5v minus 10, because I have negative 17v minus negative 12v. Then the last thing, I need to make v look like negative 5v, and the way I do that is multiply by negative 5. Negative 5 times v is negative 5v. Negative 5 times 2 is negative 10. And when I subtract, those are all going to cancel. So this times this equal the big expression underneath. So what's up top is your answer. This is your answer. This is the factor you're dividing by to find the other factor. So that's what you're looking at with division. Now, there's a special case in division, and when you're doing polynomial division, and you have to actually be able to fill in what we call placeholders. So I'm going to pick an arbitrary spot just right here, and I'm going to give you a division problem. And I'm going to make it like this. Let's not do that one. That one's a little easier than I want. Okay. That's actually kind of big. I keep changing my mind. So let's make this a little bit smaller. We'll do 8x cubed. Minus 27 divided by x minus 2x minus 3. So sometimes you'll see it written like this. So let's go ahead and write this out like a division problem. I have 8x cubed minus 27, and I'm going to divide that by 2x minus 3. Well, here's the problem. When I try to get this knocked out, watch what happens. So how do I change 2x into 8x cubed? Well, I multiply it by 4x squared. So 4x squared times 2x is 8x cubed. And 4x squared times negative 3 is negative 12x squared. Uh-oh, I don't have any x terms. Not only that, I don't have any x squared terms. Not only that, I don't have any x terms. When you have a division problem like this, you have to establish placeholders. And here's what we're talking about with placeholders. I'm going to redo this. Sorry about the program being a little fussy. Again, we have 8x cubed minus 27 divided by 2x minus 3. Now, I'm going to rewrite this, but I can't leave those areas blank. You have to do placeholders. So I have to have 8x cubed. What do you put to have a placeholder? 0x squared. I have no x's, and I have a 27. So now I can do my division by 2x minus 3. Why do I do the placeholders? Think about it as going into a crowded theater and you're trying to save seats for somebody. You can put things in the chairs. Let's say you're saving 3 other seats. You're there by yourself. You can put a purse in one seat, a jacket in one seat, and a program in the other seat. So you're holding those seats for your friends that are going to show up. And they're holding those places. You can put them there, but it still doesn't change the fact that there's only one person there, you. So you're doing the same thing here by doing the placeholders. So now let's look at the placeholders and how they work. I want to make 2x look like 8x cubed. How do I do that? I multiply by 4. Oops. Let me zoom out a little bit. I multiply by 4x squared. So 4x squared times 2x gives me the desired 8x cubed. And 4x squared times negative 3 gives me negative 12x squared. And remember, that's all subtracted. So those are gone because 8x cubed minus 8x cubed is 0. And then I have 0 minus negative 12. That becomes plus 12. So 12x squared. And then, yes, I'm going to bring down the 0x. Now I want to make 2x look like 12x squared. Well, what do I multiply it by? I multiply it by a positive 6x. 6x times 2x is 12x squared. 6x times negative 3 is negative 18x. And again, I'm subtracting. So those cancel. And then I have 0 minus negative 18, so that becomes 18x. And then I'm going to bring down the 27. Then I want 2x to turn into 18x, and that's going to be plus 9. That gives me 18x. And 9 times negative 3 is negative 27, and you can see where this is going. They are subtracting each other. They are 0, which means 4x squared plus 6x plus 9 times 2x minus 3 does indeed give you this polynomial. And that's how you do the long division without the remainder. Notice how I also had those placeholders. Those are big. The placeholders are a big deal. So now that we've looked at dividing those, what happens when we have a remainder? And I'm going to cover that in the next video. So this is just simple division, and then we'll do the remainder theorem.